This video examines the way we can machine a vehicle on the Rollon MDX20. Firstly, we look at the model and we can see several features of the model that are quite important. For example, we can see on this vehicle that we have machinable areas below the top of the object. So in this case, it's important to machine the object from the top and the bottom. If this detail wasn't present, then we could machine it on this side and on the reverse side. So two things we need to do at this stage. We need to set the origin of the work into the center of the model through our model button, and the origin now is in the center. That makes it easier to align the system. Next thing we'll do, we'll orientate the object so it's ready for machining. So in this case we'll do to be this way, and we'll select in this window the fact we're doing top and bottom. That means we end up with two windows in the machining process area, which selects the top or the bottom. However, in this case, after we machine the top, there is no way we can reference the object back to machine the bottom. So in this case, we need to bring in a model that has got retaining end plates left on the model. In that case, the model looks like this. So we've actually left on the ends of the balsa material and given us an option to flip it this way but retain the model between these two blocks. These two blocks are used to reference the object. So what we'll do now, we'll go back to the center of the object. We also need to scale the object to fit into the MDX20 format. So here we'll go into the first model window and make the x-axis approximately 200 millimeters. So now we have an object that fits into the MDX20 format, and if I select the top and bottom, we can do the top. In this case we're using these two end plates as references. So in this case we machine two retaining areas, or we machine a slightly negative shape which exactly corresponds to this, and that's used to hold the object when we flip it over. We then go into our machining process, roughing cut. We select the tool, for example 4mm square end mill. We can't do all the object because it'll just machine past the block, so we need to go partial. We bring in the region to be inside the retaining end plates, and we go to the top of the material and we machine approximately halfway. So in this case we'll have defined a machining process in roughing for the top of the object. We then create a new process called finishing. We then select again the partial area for the machining, and we select the Z to be approximately halfway, and now we've created a machining process for the finishing process. We then flip the object over to do the base of the vehicle, again with the roughing and the finishing cut. So in this case we'll have 4 steps to do, 2 for the top and 2 for the bottom. So in this case we've gone down too far. We go back to our finishing process, partial, and we forgot to select our Z. So make our Z now and create a toolpath for that. We'll now have a finishing process down to halfway through the object. And here we see the second finishing process for the bottom surface. We then select the top surface and repeat that. Again, remember, that's the bottom surface, that's our top surface. We go and do a roughing cut. We create a partial region for our area to be inside those retaining blocks. We go into our Z for halfway approximately. We create now a roughing cut, and we now create a finishing cut for that object. Partial again, select the area, select the depth, next, and now create a finishing cut. So in effect now we've done 4 processes: roughing and finishing for the top, roughing and finishing for the bottom, and we've used these end plates to give ourselves a reference when we flip the part over. So now the roughing and finishing cut is defined. We can of course simulate that through our preview. Now here we set up our cutting position. What we do is just set the center of the object to be like this. That's our origin on the MDX20. That's the center of our object. So in fact we move the object into the center of the table, and now we can simulate that, and there's our finishing cut being simulated on the machine. The other way we can machine this object is to not use the end plates, but use an alignment jig. And that's done through having a jig that we use to drill 2 holes into the wheel location pins. So in this case we orientate the model so the origin is in the center. We orientate the model so that it's actually standing up. We then put the selection for the top and the bottom of the window, and we do the same thing. We have alignment pins holding the object here, then we flip that, we'll see the alignment pins are moved over. Again, in this case we go to the top surface, we select a roughing cut, we set the tool, we select partial for our Z, which is our depth. So now we need a tool with extension of about 30 millimeters. Notice we can machine all around the object. There's a roughing cut coming through. We then do our finishing cut. Again, partial selects the depth. We then repeat that for the other surface, remembering that we're using the alignment pins to hold the object. In this case we have a square retaining section of unmachined material. When we flip the other way, we have a much harder area to hold, so there has to be some holding the material down so it doesn't move around too much on those alignment pins. So there is our top process defined. We go to our second area, again roughing, finishing in the same way as previously, and we end up with 4 processes again. So there's our depth for our roughing, and we do finishing in a similar manner. So the important process of doing these models is the jig, or retaining end material to give you a indexing point or a surface to index the part when we turn it from the top or the bottom of the object. So in summary, two ways we can define the system. We require 4 processes for top and bottom, or the sides, and we use that by defining the center of the material, and we use this window here to give us automatically our top and bottom views.